Hello everyone and welcome to another lecture. We are going to talk about exact equations today. So first let me write down what is an exact equation. So consider a differential equation of the form the differential equation will have a form of, let's say you have some function p, it's a function of x and y, and plus you have q, which is also a function of x and y, and finally you have dy dx equals to 0. If this equation over here, that is if equation 1 can be compared with a function where the left hand side of this equation will be the differential of that function, then it's called an exact equation. So let me be a bit precise. So let's say you have equation 1, and after that what you do is that you write it like this. From this line you can have it pxy dx plus qxy dy equals to 0. Let's call it equation 2. Now if left hand side of equation 2 is equals to differential, that is a total differential of a function f of xy, then we are calling equation 2 to be a exact differential equation. So our function is f of xy, and the total differential will be d of f of xy, and this should be equals to 0. So the main part is to understand that if you can have some function whose total differential is 0, then you can write the left hand side of equation 2 to be equal to this part. So let's call it equation 3. So we are demanding, that is our demand, if we assume such f of xy exists, then using 2 and 3 we get d of f of xy is equals to p of xy dx plus q of xy dy. Now this is a exact differential d of f, right? So now what we do, we expand it in terms of the partial derivatives of it. So let's do this. So this will be df dx by dx plus df dy, and now I'm not writing the xy explicitly over here, it is understood from the context. Then you have p dx plus q dy. Now if you match these things, that is the terms with dx, it has this df partial of df dx, the partial derivative of f with respect to x, and this should be matched with p, right? So p is df dx, or in a shortcut notation you can write it as just f of x, where x is now on the subscript. Similarly q will be df dy, and you can write it as f of y. Now since this is an exact differential, that is the function it satisfies equation 3, an exact differential, and it's a function of two variables x and y. We know from our calculus that the second derivative, that is the mixed derivative part, are same under the switching of order of differentiation. So if I write it mathematically, we already know this. We know this identity, right? Or you can write it as xy equals to f of yx. Now, using these three informations over here, let's say 4, 5, and 6, our target is to find whether this kind of f exists if the equation is exact, and to check the equation is exact, we will derive one condition that I haven't discussed yet. So if our equation is exact, our ultimate target will be to find that f of xy will contain our solutions implicitly. So using 6, now using 6, you have your f of xy is equals to f of yx, right? So let's write them like this. But what was f of x? It was p. So f of xy, that is this mixed derivative, will be now p of y, right? That is partial derivative of p with respect to y. Similarly, it will be q of x. So if this condition over here, if this condition is satisfied by the given differential equation over here, that is 2 or say 1, whatever you want to call it, you just identify p and q and you check whether this is true. If this is satisfied by the given differential equation, we call that equation as an exact differential equation. And this will be all for the theory, because whenever you can identify your equation as an exact equation using all these informations over here, that is py equals to qx, and that is the thing that will assure you that this is an exact equation. Then using 4 and 5, because you can see that this 4 and 5 tells you that f of x, that is the partial derivative of f with respect to x, is equals to p. So using these tools, so let's say using 4 and 5, we can write f of xy as integration of p. Okay, yeah, we have to integrate with respect to x, so p dx. And now you might think there is a constant, right? But it's just not a constant, it's a constant with respect to the x variable. So the general constant will be just a function of y, like this. Or you could use 5, and write f of xy as q dy, and now there will be some function h of x. Any of this will do. And in the next video, we are going to see an example how we can solve an exact equation. Thank you.